In this video, we're going to practice finding the derivative of trigonometric functions. Now, the one thing you need to know, as soon as I say differentiate, you need to remember all of your rules: the power rule, the chain rule, the product rule, and the quotient rule, because you may have to resort to any one of these in order to differentiate a function. The function that I've got here is a composite function. In other words, it's made up of two functions. My outer function, which I'm going to call f of x, is the function sine x. The inner function, which I'm calling g of x, is 5x. If I've got a composite function and I want to differentiate it, I need to use the chain rule. So finding the derivative of y in the variable x is going to be the derivative of f of x. Well, the derivative of sine x is cos x. And then I times that by the derivative of the inner function, and the derivative of 5x is 5. Just because I like to write my coefficients first, I'm going to rewrite this so that it is 5 all times cos of 5x. Once again, in this example, I've got a composite function. This time, instead of two functions, this composite function is made up of three functions. So let's see what my functions are going to be. My outside function is my function f of x, and that's the function that I'm going to call x squared. Now at this point I'm going to pause looking for my functions that make up the composite function, and I'm going to go back to the function y, and I'm going to rewrite it so that you can see that x squared. If I take the whole ratio, cos 3x, and I square it, I've actually written it just in a different way. Hopefully now you can see the x squared. Inside that function, I've got g of x, and g of x is cos of x. And lastly, h of x is the angle, which is not a simple angle, it's 3x. So now if I find the derivative of this function, I'm going to find the derivative of f of x times by the derivative of g of x times by the derivative of h of x. So the derivative is going to be, the derivative of x squared is going to be 2x. So that's going to be 2 cos 3x. Timesing that by the derivative of cos of x, which is minus sine of x, that's going to be minus sine of 3 of x. And lastly, timesing that by my last derivative, which is the derivative of h of x, I must times that by 3. Once again, this is not a necessary step for you to do, but just so that it looks neater, I'm going to write that as minus 6 cos 3x sine 3x. Before starting to differentiate this function, I can see that it's a product function. The x is my first function, and tan x is my second function. So I times f times g. Using the product rule, I'm going to continue as follows. So the derivative of my function must be the derivative of f, which is 1, all times by g, which is tan x, plus the derivative of g, which we discovered was sec squared x, all times by f of x, which is x. Writing this down again so that x is not confused with the angle of sec squared x, this is better written as follows. So I write x sec squared x. And in question 4, I'm asked to find the gradient of the tangent to my function, which is given by f of x. If I want the gradient of the tangent, I must find the derivative of f of x. As my function is made up of two other functions, one in the numerator and one in the denominator, I need to use my quotient rule. And each of these functions is a composite function. So when I do the derivative of the numerator, I must remember to do the derivative of sine of x times by the derivative of 2x, and in the denominator, the derivative of cos of x times by the derivative of 4x. So let's start. If I want to find the derivative of this function, and I use my quotient rule, I say find the derivative of the numerator function. The numerator function has got two functions in it. So the derivative of the outer function, sine of x, is going to be cos of x. So I write cos 2x. I times that by the derivative of the inner function, which is 2. And I must still times all of that by the function in the denominator, which is cos 4x. Then I minus. In the second term, I take the derivative of the bottom function. Like the top function, it's also a composite function. I find the derivative of cos of x, and that's going to be minus sine of x. So I write minus sine 4x. Then I take the derivative of the inner function, 4x, and I times that by 4. And lastly, I must still times that by the function in the numerator, and that is sine 2x. To complete the quotient rule, I must write all of this over the function in the denominator, which was cos 4x all squared. So that's going to be over cos squared 4x. Now this looks very daunting. It's quite a confusing expression, but you don't have to worry because all I asked for you to do was find the gradient of the tangent at x is pi over 6. In case you're not very good at tidying up your expression, I'm not even going to do that in this next part of the sum. I'm just going to find the derivative straight away when x is pi all over 6. In other words, in my expression, wherever I see an x, I must write pi over 6. So I'm going to write 2 times cos of 2 times pi all over 6 times by cos of 4 times pi over 6 minus, in fact, can I write that as plus 4 just to make it easier for me? And then that is times by sine 4 times pi all over 6 times by sine of 2 times pi all over 6. And I write that all over cos, and I'm going to write that as 4 times pi all over 6, and I'm going to take that whole ratio and square it. Now, so long as your calculator is in radians, then you can put a fraction into your calculator and type this exactly as you see it on the screen, and you'll get the gradient. So the gradient, which is the gradient of the tangent using the derivative to this particular curve, is going to give you an answer that the gradient when x is pi over 6 is going to be 10. Your tangent has an increasing gradient of 10 at this particular point on the curve.